So when using your kinematic equations, what we need to do is break down the problems and figure out what exactly we're given. From there, we're going to match an equation which to use. So in the first one, we had a car that accelerated from rest to this velocity in this time. So anything that's from rest is 0. If it comes to a stop or comes to a standstill, that would be a 0 for a final velocity. If they ever say something that there's an average velocity, that means both VI and VF would be the same. So we had these 1, 2, 3, 4 equations because they asked for acceleration. So the only equation that had all 4 variables in it was this guy. So you plop in the equation, put everybody underneath where they belong, and then just kind of start reworking it. Since this was 0, 26.8 minus 0 is still just going to be this. So it's 26.8 is equal to A times 5.1, which is just, if you guys thinking about it, it's like 10 is equal to 2x. Get x by itself. Divide both sides by 2. So what you did here was divide both sides by this 5.1. Got your answer. Acceleration is meters per second squared. In this distance equation, all right, if you have a VI of 0, then it's going to be 0 when you start working through it. If it's not 0, you subtract it from both sides, which is what we see something similar in number 5 over here. Okay, we were given a VI, VF, D, and A. The only one that had that was this guy up top here. So we worked it out. You have to get rid of this guy first to subtract it from both sides. You can wind up with a negative acceleration, guys, so don't freak out over that. Can't have a negative distance, though, or a negative time. Yeah, and then kind of go through and work these out. So then for our homework here. Now, I didn't give you guys the equation on this one. So for this one, I kind of give you like a sig fig answer. So it should be very, very close, if not exact. Okay, if it's not exact, don't freak out, but it should be like pretty close. So we're going to do number 1 together, or at least do the setup. So an airplane accelerates down a runway at an acceleration of 3.28 meters per second squared for 32 seconds, 32.8 seconds, until it's finally off the ground. Determine the distance traveled before takeoff. Okay, so what am I given? Right off rip, I'm given an acceleration of 3.20 meters per second, control period squared, control period again to get it back out of that. What else am I given? I am given t. Time here is equal to 32.8 seconds. What else? Am I given anything else? Well, all these equations have 4 variables, so we need to have one more. What are we thinking? All right, so you guys seen planes? You ever been on a? Let's just think of this. All right, you've been on a plane before, going on vacation. Usually at like this at very start of the runway, plane sits there, it's just idling, and then it comes to a stop, gets the okay from the ATC, and then starts to take off. So initially, what is our speed? 0. All right, and then they wanted us to figure out the acceleration. I'm sorry, no, the distance. Okay, so which equation has these 4 variables? This one does not have D in it, so that's immediately eliminated from contention. That means we have one of these 3. Is there a VF in our given information? No, so that means these 2 are canceled out. So process of elimination. This is the guy. So I'm going to Control C, scoot this over, Control V. And then just going to kind of go underneath everybody and solve. Don't know what D is. VI was 0. Time was 32.8 plus 1/2 A, which was what? 3.20 times t squared, which was 32.8. Now you remember, in this equation, you're only squaring time. So this becomes 0. And then 1/2 times 3.2 times 32.8 squared. So if I do 32.8 squared, let's do that real quick. 32.8 squared is, Jesus, 1,075.84 times it by 3.2, and then divided by 2 because it's the half mark, right? Cuts it in half. The 0 doesn't do anything for us here. So this is going to come out to be 1,721.34. So, like I had said before, guys, answer, it's pretty close. This was a rounded sig fig answer. 1,720, 1,721.34. Pretty spot on. So if it's not exact, don't freak out. These are probably like rounded answers or sig fig rounded answers. So what you probably, first thing I would do for all of them is figure out the variables first. Figure out my variables, and then I can figure out the equation, and the rest is pretty easy. You have examples to go back and look through. So starting from rest, snap, VI right off rip. It accelerates at a constant rate over a time of 5.21 seconds for a distance of 110 meters. Determine the acceleration of the car. So VI, T, D, and A. This one doesn't have D, so that's automatically out. So you have one of these three, but we don't have VF. So these two are eliminated. So we're using the same equation that we just had used for number 1. To get guys credit for this, you have to show the full work, okay? Because the answer's already there. So if you just put an answer, you're not going to get any credit. Okay, you got to show the process of going through and getting this. Here, we got a bike that accelerates uniformly from rest, VI is 0, to a speed of VF 7.10 in a distance of 35.4 meters. Determine the acceleration. So what equation has VI, VF, D, and A? Doesn't have D, so it's not in there. This one doesn't have VF, so it's not in there. So I'm looking at one of these two. Well, we're looking for A. We don't have time, so it's got to be over here at the fourth one. Okay, now this problem. An engineer designing a runway from an airport. Oh, one of the planes. So the lowest acceleration rate. Okay, so we're given an A is 3 meters per second squared. Then what else? Starting from rest, so VI. Jesus. And the takeoff speed needed at least will be this 65 meters per second as our VF. Okay, assuming that this is the minimum acceleration, what is the minimum length allowed? So we're looking for D as our question mark. So VI, VF, A, and D, it's going to have this, it's going to use this same equation here. It's got all of our variables. Okay. In number 5, we have a car that's traveling at a certain speed, skids to a stop in this time, determining the skidding distance, assuming that there is a uniform acceleration. So what were we originally traveling at? This 22.4 meters per second. It says we come to a stop. Well, if you come to a stop, that means your final speed would be 0. How long did it take you? 2.55 seconds. And then they want to know, determine the distance that you skidded or skid. Is skidded a word? I don't know. Maybe, possibly. Who knows, to be honest? All right. And so which equation here, guys, has all 3 or 4 of these? 1, 2, 3, or 4? This looks like it's the winner. Okay, and 6 is just like the last one from the previous like from the previous work. It's just different numbers. All right, so you guys have have your equations for you to go through and to work for. Okay. All right.